and all that sort of stuff. I just want to confirm you can see my screen, everybody.
Yep.
Sweet. All right. Well, my name is Isaac Levin. I am a .NET developer advocate at AWS. If you do not know who I am, I talk about .NET and cloud things and DevOps things, and I'm pretty active on different tech social medias. You can find me and follow me if you like. Twitch, GitHub, Twitter. Isaac R. Levin is my handle. I'm also Microsoft MVP. I'm also the marketing chair of the .NET Foundation. So thanks for Carl for shouting out the .NET Foundation as a sponsor of this meetup. And if you like hearing my voice, I also have a podcast where I talk with miscellaneous people in technology. Usually every week. It's called Coffee and Open Source. It's the actual chats are live on Twitch, and then they're on demand on YouTube. But then we have a podcast that goes out to all of your podcast clients. So Coffee and Open Source, if you're interested in that. I've interviewed folks like Scott Hanselman, Kelsey Hightower. I'm interviewing next week Chris Nova, who works at GitHub, if you don't know who Chris is, and a bunch of other people. I'm doing it for a few years. Definitely, if you like hearing about people talk about their passion, which is technology and open source, give that a listen. Coffee and Open Source. So with that, we've had a couple of folks already kind of chime in what their experience is in AWS. I'm going to move my chat window over here so I can see folks talking real time. Yeah, I think the biggest thing that I want to get out of this particular presentation is how, what your experience is. If you have concerns, if you have feedback, want to be a conduit between that and our service and product teams around making sure the .NET experience in AWS is great. This talk, I've delivered this talk a few times, like I mentioned, but I'm always looking to get feedback. So if you don't like the talk, if you do like the talk, please be honest. I know, my friends from the UK, they never have a hard time saying when they don't like things. So hopefully we can keep on rolling. But anyway, so let's just get started. And obviously, if you have questions, you can ask them in the chat. I'll try to pay attention to it, but you can come off mute as well and say hello. Yeah, so with that, let's get started. So I think it's really, really important to talk about kind of what we're covering today. So first, so this talk, just for some context, it's going to go over all the different options that we have for building apps on AWS. So I've kind of categorized them into a few different, I guess you can say, categories. And the first that I'm going to be going over is traditional compute and how we can leverage that to build on applications today. And then after that, it's more than likely that most of the folks here, they have heard of containers. At least they've seen Microsoft and the .NET team talk about containers, and I just talking a little bit in general about hosting containers in AWS. And then finally, we're going to talk about some of our serverless platform offerings and how we can take just the chunks of code that we want to write in .NET and do we write in .NET and run them without having to worry about underlying infrastructure. But before we start talking about the hosting options, I think it's really important to talk about the tooling that we have that AWS has built out to make the .NET developer experience excellent. So when it comes to building .NET apps, like I mentioned, we want great tooling, and there's no better place than having great tooling than in your IDE, right? AWS has built-in extensions for your favorite IDEs. So whichever that is, Visual Studio 2019 or 2022, Visual Studio Code, JetBrains Writer. We have exceptional experiences where you can not only manage your AWS resources, but also do deployment experiences as well. And these extensions, they're available for free, going through the different marketplaces that exist for those particular IDEs, tightening that developer loop and helping make sure developers can be effective when they build things on AWS. Secondly, if you love the command line, AWS also supplements these IDE extensions, like I mentioned, with CLI tooling to help automate your workloads. So we have the AWS CLI, the AWS tools for PowerShell, and multiple other CLI-based tools. And for instance, one great tool specific for .NET developers is we have the .NET Deploy Global tool, which is an interactive experience in the terminal window that allows you to facilitate the deployment of your application to AWS right from the command line. So really, really cool stuff. And there are a plethora of other tools that AWS provides to make the life of a .NET developer better. And I really want folks to take a look at some of the stuff we're building. And if you have any questions about that, feel free to put them in the chat or just ask them out loud. So let's quickly go over some of the compute options that exist for AWS for .NET applications. There's a plethora of them. We're going to mention a few of them right now that I see are pretty canonical. So let's start with Amazon Elastic Cloud Compute, which is EC2. EC2, they're securable or sizable compute platforms that can run basically any workload. So for us as .NET developers, you can have a web service with IIS on it, for instance, where we can manage the apps using processes that we're familiar already with, right? So if you have a ton of flexibility and configuration of EC2, and you can specify the processor architecture you want. For instance, .NET now has really great support for ARM64 as of yesterday. So being able to build out those environments and to build out the host operating system you want with having that full configuration and flexibility. And secondly, if you're building web applications that you want to be low cost, Amazon Lightsail is a great option. Lightsail, it's a VPS, which stands for Virtual Private Server. And that enables you to create an application from the AWS console in just a few clicks, but also scales as you grow. And this is great. This is a great option for spinning up test environments. For instance, if you have a PR environment that needs to get tested, being able to spin those up, tear those down pretty efficiently, that's one thing. Great thing that you can do with Blazor. And then finally, which a lot of folks might have heard of or are familiar with to some extent, is AWS Elastic Beanstalk. And that's a service for deploying and scaling web applications, specifically giving you a ton of flexibility, but it's more abstracted from EC2. Elastic Beanstalk, it's a great option for web servers, backend processing, because there's managed platform updates and built-in application monitoring tied into the platform itself. So let's talk a little bit in detail about what EC2 is and what it isn't. So basically, E2, they're purpose-built virtual machines. So if you come from Azure world, or even if you come from on-prem, like they're virtual machines. And you can specify a template, which is a predefined image based on your preferred operating system. And that includes different versions of Linux, or you can have Windows Server as well. And EC2 provides flexibility to configure the software that you want on the machine because it's a virtual machine, right? So you got to manage the patching yourself, manage different miscellaneous operating system requirements, but that's all done. And you have that configuration to really build what you want the way you want it. One thing that's really, really important to call out is that even though they're virtual machines, there is scalability built into them. So there's this concept called EC2 auto scaling, which allows you to build highly scalable applications that you configure scale rules for EC2, and they handle that change in capacity as necessary. And then if you're not familiar with AWS in general, or some of our Amazon free tier offerings, we have things like spot instances, which are really, really great for cost savings. They give you a ton of flexibility, but there's also an Amazon or AWS free tier. And specific to EC2, you can build up a micro EC2 instance and get that VM for a year from when it's turned on. So again, just shows you that we're trying to enable developers, and we understand that the cloud can get very expensive very, very quickly. And being able to provide some compute, some services at a really, really low cost or free is really, really important. So that's EC2. Let's talk a little bit about Lightsail now. So Lightsail, they're pre-configured development stack. So for instance, we have Node.js or Nginx or different flavors of Linux as well as Windows Server. So if you want a Windows workload, there's Windows 2022 support. And the setup experience is you literally go into the AWS console, you click a button, you specify what you want your template to be, and then within a minute or so, you have a VPS, virtual private server, like I mentioned, that has pre-configured SSH and the ability to configure it the way you need it. And this is really, really interesting because, like I mentioned a bit earlier, when you have environments that you want to be able to create really quickly, but you don't need all of the flexibility of a proper VM, Lightsail is really, really interesting because you can just spin them up, tear them down in a very, very quick amount of time. And I know that this is kind of raw compute, this section I'm talking about. So, probably asking me why I just mentioned containers, but Lightsail has options for doing containerized workloads as well. All that one-click solution. And Amazon Lightsail also comes with more simplified load balancing as well as CDN. So it gives developers the ability to make sure that no matter where their customers are, their applications will always have that low latency and response time. So that comes in the box. There's no additional configuration needed or anything like that. And finally, like in the situation where you might outgrow the capabilities of Lightsail, you can seamlessly upgrade to EC2. So that's ideal when if you're trying to get started in the cloud, you want to just build some .NET apps and deploy them out to some instance, and then eventually you mature, the application matures, you can then move to a more flexible platform from EC2. So what does it mean when you run EC2 or running .NET on EC2 or Lightsail? So as it pertains to building or running these apps, there are tons of processor and operating system options you can deploy to. For instance, you can choose x64, x86, ARM, as well, like I mentioned, all those different flavors of Linux, Ubuntu, Windows. And if you're running those workloads specifically, maybe you have some .NET Framework applications. So there's support for Windows Server 2012 all the way up to 2022. So those are currently supported with .NET Framework pre-install them. As we all know, .NET Framework ships Windows. So you get that experience of deploying in a mechanism that you're already probably familiar with, right? So if you have on-prem environments, on-prem VMs, being able to deploy them is very, very similar to how you would do it in the cloud. And finally, when we are installing like newer versions of .NET. So like .NET 7 just came out yesterday, so I had to update this slide deck. It's the simplest running scripts that for your specific OS that are provided by Microsoft. Like for instance, if it's Ubuntu, like now you just do apt-get install .NET 6, which is absolutely insane to me. But if you have a non-Ubuntu flavor of Linux, and you kind of want a more flexible approach, like this is a code snippet of downloading a tarball from Microsoft's CDN and unzipping that tarball and then setting your path variables to .NET. So that's in a nutshell how we can run .NET on EC2 and Lightsail pretty seamlessly. But let's talk a little bit about choosing between these two services, because you're probably thinking, well, Isaac, they both sound like VMs to me. So in what situation would you want to use Lightsail, or which situation would you want to use EC2? So let's start with EC2. So some of the scenarios that you want to use with EC2, if you have enterprise grade applications that need scale almost immediately. So EC2 is a great option for that. Also, if you want that configuration, like maybe you have an IT organization that needs a lot of flexibility, a lot of configuration, maybe you have engine or agents that run these machines to make sure that you're adhering to companies' policies. That sort of experience, that's really great for EC2 because you manage the entire operating system. And like I mentioned, if your folks are already familiar with managing virtual machines, like they RDP into Windows and they're doing all these things in IIS or Active Directory or what have you, being able to do that in a familiar experience is really reliable. So we're switching to why go to Lightsail. So Lightsail, like I mentioned, it is kind of a dumbed down isn't the right word, but it's kind of a filtered down version of EC2. So it's far more cost effective. It gives you the ability to just provide some surface for you to send your app to, but you still get that flexibility. You still can SSH into the machines. You still can configure some of the underlying OS mechanisms. But you don't have to bear the weight of like a larger virtual machine and having to manage that with the cost and all those other things. And also EC2 comes with a bunch of built-in metric collection. If you don't need those for whatever reason, like again, maybe you have a test environment that you just want to test functionality, EC2 doesn't have those sort of things, or I'm sorry, Lightsail doesn't have those sort of things. So again, it's kind of like a filtered down version of EC2 at a substantially lesser cost. All right. I have a quick demo to show you just how quickly it is to set up an environment with .NET 7 and EC2. So I already created, let me just pull up my handy dandy browser. So right here, I'm in the AWS console. If you haven't seen this, this is kind of like the Azure portal, but for AWS. And before we started today, I set up a new EC2 instance, which is what we call VMs. And I configured SSH on there, as well as set up .NET 7. So what I can actually do inside the EC2 console here is I can click this connect button, and then it gives me, if it refreshes, it gives me a command to be able to SSH into the box. So let's actually pop up my command line here. Let's go here for downloads. So in here, I downloaded the PEM file for my SSH to make sure that I have a secure connection. And I'm just going to paste that particular command that I copied from there. So as you can see, I'm in Ubuntu. And I can do something like uname -a. And as you can see, I have Ubuntu and it's x64 and all that sort of great stuff, right? So let's minimize this. So inside of this home directory in Ubuntu, I have a .NET on AWS folder. So if I cd into there, as you can see, this is just a simple .NET API template that I spun up. It's in .NET 7. So I can do like cat .NET on AWS. And as you can see, it's .NET 7, right? So again, folks have all seen this a million times, but it's good to show you that I'm doing this inside of a VM that's in AWS. So what I want to be able to do is I want to take this application and I want to run it in my environment. And I want to be able to have that particular application accessible via the internet. So I can just do a .NET run here, and then I can specify some URLs. And what I'm going to do here is I'm going to specify some URLs that are going to map the ports for my particular application that I'm running. So the nomenclature for that is 5000 and 5001, which you're probably familiar with. This is just making sure that I can guarantee what port these are going to run on, because sometimes they would not run on this port. So let's do that. So this is going to do typical .NET CLI things. It's going to build it, it's going to run it, and then we're going to see here we're running on port 5000 and 5001. So nothing crazy at this point. So now I'm inside of the AWS console, and if I just go to this particular endpoint here, and this is not going to return anything. Let me just get this toolbar out of the way, get out of the way, toolbar. So like even if I went something like this, 5001, it's not working still because all of my ports are blocked right now. So what I actually need to do is I actually need to go into the AWS, the EC2 console, and open up this particular port. So I can do that by going to the security tab here. And then I have these inbound rules here. As you can see, 443 is opened up in 2022 because I'm SSHing in there, and then 80 as well. So I can go into the security group and I can edit these inbound rules. And then it's as simple as adding a rule, specifying a custom TCP, and let's just open up the 5001 port. And then I can specify what I want my source to be. I can specify anywhere. I can just specify my IP address. So what I can do is I can click save those rules. And what I've just done is I've enabled the 5001 port only accessible from my machine. So then I can do something, and I can just refresh this. It still doesn't work because I'm running an API, right? So if I go to weather forecast, right? So now I have just the canonical .NET API template running in EC2. This is .NET 7. So it's latest versions of .NET running on Ubuntu, exposed via those ports like I mentioned earlier. So again, very, very simple demo of just showing like, oh, you have the flexibility to install .NET 7 on these machines. You have the ability to open up ports on these machines. And I'm running Kestrel in this particular case. But if this was a Windows VM, I could easily host this .NET 7 application behind IIS and then have all the great experiences that I have from IIS there. So that's really cool. Let's move on to kind of the next section, which is talking about another compute option, which I think is a bit more managed than the ones that I just mentioned earlier, right? So for instance, if you haven't heard of Elastic Beanstalk, so Elastic Beanstalk is a service for deploying and scaling web apps, like I mentioned earlier, and it has a quick deployment mechanism, and it's kind of like a managed VM, to say the least. So like if it's a Windows particular, if you're building a Windows environment, it's kind of like a managed version of IIS. And what's great about it is that you simply upload your application, and Elastic Beanstalk automatically handles that capacity provisioning, the load balancing, the scaling, the health monitoring, all that great stuff. So Elastic Beanstalk, so how it works is you specify a platform, and we'll talk about what the concepts are in a second. You specify a platform that you want to run. You can build applications like in Go, Java, Node.js, obviously .NET. But it gives you that flexibility to kind of specify the platform version and the operating system that you want this to run under. So it runs EC2 under the hood, but all that is managed and obfuscated away from you or abstracted away from you. And if you you can access, you can interact or configure Elastic Beanstalk through the AWS console, but you can also do it from the CLI, like I mentioned earlier. There's a high-level CLI designed specifically for Elastic Beanstalk called EB. So take a look at some of that stuff if you want. So let's take a bit to talk about why Elastic Beanstalk is an interesting option. So firstly, Elastic Beanstalk has the seamless getting started experience. So it's in just a matter of minutes, you can go from having nothing to having a .NET application hosted in the cloud very, very quickly. It's also highly scalable because scale is built into the platform. So you don't have to configure auto scaling. It's just auto scales for you. And then it has hooks for modern DevOps practices. So for instance, GitHub Actions or Azure DevOps or what have you. And it supports multi-tenant architectures. Elastic Beanstalk is also highly flexible and it simplifies operations while being pretty cost efficient, more cost efficient than just owning a bare bones virtual machine. So let's talk a little bit about the concepts of Elastic Beanstalk because they are a bit foreign when you first starting started. So let's just talk a little bit about when I say some of these words and when we talk about Elastic Beanstalk, this is what they actually mean. So let's start with what an application is. So in the Elastic Beanstalk world, an application is a logical collection of Elastic Beanstalk components. So that includes environments, versions, environment configuration, and in Elastic Beanstalk, an application is conceptually like a folder. So think of it like, just think of an application as like a folder. So next we have an application version. So in Elastic Beanstalk, an application version refers to a specific labeled iteration of that deployable code for your web application. So the application version points to an Amazon simple storage service. So that's like an S3, kind of like a storage bucket. And that contains your deployable code. So when I mean deployable code, it's like the output of like a .NET publish command, for instance. And an application version is part of an application. So applications can have many versions, and each application version is specifically unique to that version. So in a running environment, you can deploy any application version you already uploaded to the application, or you can upload and immediately deploy a new application version. So you could upload multiple application versions to test differences between one version of your application and another. So like a great example is something like blue green deployments, right? So being able to test different features or different versions of your apps without having to spin up other resources and all sorts of things like that. Next, let's talk about the term environment, because environment has a very specific purpose in Elastic Beanstalk. So an environment is a collection of AWS resources that runs an application version. So each environment runs only one application version at a time. So you can run the same application version on different application versions in many environments at the same time. When you create an environment, Elastic Beanstalk provisions all those resources that I mentioned earlier, CPU, memory, what have you, and needed to run replication specified. But it also does things like spinning up databases, spinning up caching if you need it. And finally, like when you launch an application, you use an environment tier. So an environment tier designates the type of application that environment runs and determines what resources Elastic Beanstalk provisions to support it. So there are two environment tiers. We'll talk about them in a bit more detail in a second. But there's web server, which is a traditional application that handles HTTP requests, and a backend environment, and that's more of a background processing sort of scenario, and that uses Amazon Simple Service Queue. Simple queue service, actually, SQS, to run, and that's called a worker environment tier. And there's a few more concepts that I think are important to call out as well. So environment configuration that identifies all the settings that define an environment and its associated resources. So when you update an environment, that configuration is stored in Elastic Beanstalk, and though it automatically applies those changes to existing resources or deletes and deploys those new resources. We also have save configurations, so you can have sort of like, you can have templates for deploying the same instances of your applications, and those are all available like through the CLI or the APIs. And then the last one, which I think is probably the most important, is this idea of a platform. And a platform is a combination of a few things. So it's the operating system, the programming language runtime, the web server, the application server, and all the Elastic Beanstalk components to make all of that stuff work. So you design and you target your web application to a platform. And Elastic Beanstalk provides a variety of platforms of which you can build your applications on, .NET being one of them. So here's a simple diagram of a workflow for Elastic Beanstalk. So the first thing is if you have, you create your application, so that, and then you upload that version of the application. So when I say uploading a version, that's, like I mentioned, like a .NET publish command, the directory, your bin directory, your publish directory, what have you. And what that does is that launches an environment and creates and configures all those underlying AWS resources needed to run your code. After your environment is launched, You can then manage your environment, deploy new application versions, kind of using this SDLC sort of circular model. And this diagram, like I said, mentions that. So after you create and deploy your application, information of the application, including metrics and events and environment status, that's all available through the Elastic Beanstalk console, the CLIs, all sorts of different places, right? So it just gives you that secular, like our applications are never like done, right? Like there's always, we need to, we get a bug, we need to push a new version, whatever. And it's just Elastic Beanstalk kind of has that concept, that way of thinking built into the platform. So let's talk a little bit briefly about the different tiers of Elastic Beanstalk, the different types of Elastic Beanstalk environments. So those environment tiers, like I mentioned earlier. Let's start with the web server environment. So these are all the components that underlying get created when you stand up an Elastic Beanstalk web service tier. So when the app receives a request, Amazon Route 53, which is the routing mechanism, sends requests to an Elastic Load Balancer. And going forward, that load balancer shares the request across all of the EC2 instances that make up Elastic Beanstalk. And every EC2 instance has their own security group, which means that they're, they're segmented off from the outside. And those EC2 instances are all part of one auto scaling group. So you get scaling and security in all in one bucket. So that auto scaling group, it automatically starts additional Amazon EC2 instances, and if scale down events are needed as well, that's also handled by that same group. Elastic Beanstalk, the entire application, has a default security group, and that can act as a firewall for those EC2 instances, and I mentioned that a bit earlier. But these groups can also establish security groups for other services. For instance, if you have a SQL server that's hosted in Amazon, like an Amazon RDS database, for instance, that your app needs to connect to, that can be handled in there, and you have that ability to manage these security groups from that. And for more back-end services jobs, apps that don't have a front end, that's a great opportunity to use that as a worker environment here. So what I mentioned earlier, it provisions an Amazon SQSQ, and if you don't already have one, when you launch that worker environment, Elastic Beanstalk installs the necessary support files for your programming language of choice and a daemon on each EC2 instance. And then in that same scaling group that I mentioned earlier, that daemon reads messages from that same SQSQ and sends data from each message that it reads to the web application running in the worker environment here for processing. So if you have multiple instances in your worker environment, each instance has its own daemon, but they all read from the same queue. So it's one of those things where if you need to have different queues for different mechanisms, you probably need different instances of Elastic Beanstalk service to be able to do that. All right, so now we're done with compute options. Hopefully that was helpful for some folks. We're going to talk a little bit more about containers, which is super exciting because there's a lot of great stuff that just came out from .NET Conf specifically around containers. So let's just talk about some of the different services in AWS that are available to us if we're building containers today. So if you're building a ton of apps and all those apps are hosted in containers, you more than likely have a ton of Docker files and images sitting around. And you can easily store these container images in an Amazon Elastic Container Registry or ECR and manage as well as deploy them to the container service of your choice. And the first place that you should look when you're building .NET apps and containers is Amazon Elastic Container Service, or Amazon ECS. And ECS is a managed container orchestration service for containerized apps. Because the container ecosystem is fully managed, we get access to seamless integration with AWS management and governance services, as well as an opportunity to save up to 50% on cost, which is awesome because you get automatic provisioning built in, auto scaling built in, and pay-as-you-go pricing. We also have an Kubernetes flavor. So if you've probably heard of Kubernetes at some point and the value that it can provide for building microservices. If you want to host your containerized apps in Kubernetes, we have a managed version of Kubernetes called Amazon EKS, or Amazon Elastic Kubernetes Service. And both ECS and EKS, they provide a ton of value, but the orchestration is dependent on those particular tools. If you want containers, but you want to ensure that you have the most efficient of your state, you're making the most out of the instances that you have. AWS Fargate is a serverless compute engine for containers. Because it's fully managed, you just focus on your app. So we'll talk a little bit about what that means in a second, but don't have to worry about scale, don't have to worry about patching, don't have to worry about load. All those things are built into Fargate's orchestration model. And Fargate is compatible with both ECS and EKS. So you have a ton of container options. But there is a situation where you want containers and you just want to deploy them in a containerized way to the cloud. You might not have any cloud infrastructure experience. You just might not care. So in that case, well, there's AWS App, which is a great option for you. And we'll talk about what each of these services are right now. So let's talk a little bit about ECR specifically. So let me just give a little bit of context. So when we're talking about containers and hosting them, regardless if it's locally or in AWS, we need to be aware of the definition of our application. And for folks new to containers, that definition is called an image. So for storing images of our containers, we should use a registry because that allows us flexibility to not to ship that definition of our containers wherever we need them. So there are a ton of popular container registries out there. And if you use them, you also get additional benefits like caching and authentication. So the process to deploy your apps is even simpler. And as one would expect, Amazon or AWS has a container registry, and that's called Amazon Elastic Container Registry, or ECR. If you're building apps that run on containers, you should look no further. If you're building apps that are running as containers in AWS, you should be looking for ECR as a great option for there. So ECR comes with cross-region and cross-account replication, which makes it easier for you to have your images where you need them as close to the container services as possible. It also comes with pull-through caching. So what that does is that provides a mechanism to cache repositories that may live in remote public registries, like Docker Hub, for instance. Doing this ensures you have the latest version of that image as close to your ECR instance as possible, which greatly reduces latency when we are pulling down those images and building out our containers. And the largest benefit to using ECRs is deep integration with other AWS services, so such as Elastic Container Service or Elastic Kubernetes Service. Having this integration allows you to have all your container-related workloads in an all-one centralized management experience, and that's the AWS console that I was showing you a bit earlier. I mentioned the ability to set up private registries that you can sync public repositories to, and what that brings a heightened level of security to ensures our images are never pulled down to locations we don't want them pulled down to. And taking that a step further, ECR has built-in container image scanning, which can be helpful to identify and prevent potential vulnerabilities, so you're aware of a dependency that might be compromised. We might not be Java developers in this room, but most of us have probably heard of Log4j, right? So those security concerns, if you have built-in container image scanning and you reduce the surface attack area and you reduce the risk of potentially being in a vulnerable situation. So important thing to call out. Let's talk about some of the different ways that we can host containers. So ECS is, like I said, it stands for Amazon Elastic Container Service, and it's a highly scalable container management service. And we can use it to run, stop, and configure those containers that are in a cluster of containers. With ECS specifically, your containers are defined in a task definition that's used to run an individual task or task within a service. And when I say service in this context, I'm referring to a configuration that we basically define to run and maintain a specific number of tasks. ECS has like a ton of really great features out of the box. So like I mentioned a bit earlier, there's auto scaling, so being able to scale your app as it gets higher load. Those auto scaling group capacity providers just are turned on for you. And how that auto scaling works is there's two custom CloudWatch metrics. So CloudWatch being it's kind of like Azure Monitor, but in AWS. So you have those custom CloudWatch metrics running, and you target a tracking scaling policy attaching to that auto scaling group. And then when those metrics are fired, Amazon ECS then manages the scale and scale out of that auto scaling group for you. ECS is also quite cost effective, like almost every other container offering, because you get smaller compute sizes than hosting applications and virtual machines. I mentioned a bit earlier that you can run all sorts of different tasks on ECS, so smaller tasks or even enterprise scale applications. And how this is done is that ECS manages the clusters of EC2 instances. So those VMs we were talking about earlier, ECS manages those EC2 instances for us. And we have things like container orchestration tools that are installed on those EC2 instances. So ECS has access to those tools to enable patching of the instances as well as scale up and scaling down. If I can just get how is this going for everybody? I want to make sure that everybody's kind of following along. This is, I know that I'm talking a lot about services, but I have some demos planned in a second. But how's everybody doing? Give me some thumbs up if you're liking the content. If you're not liking it, I can kind of pivot and we can do a little bit else. I just want to kind of test the room because I've been talking for a bit now. So let's talk really briefly about how ECS actually works. So as I mentioned before, Amazon ECS is a cluster of EC2 instances. So when a task is instantiated, that task definition defines all the containers that form your application, and that's triggered. So all the required container images are then pulled from your container registry. That could be ECR, Docker Hub, or somewhere else. And those images are used to build the containers, and the requested task is then run. So this is all managed by the container container agent, that on the instances, and that's all managed by ECS. If I can get a thumbs up if people here who use Kubernetes, or at least have heard of Kubernetes, that'd be great too. So if you're already using or building or deploying containers in Kubernetes-like environments, there is Amazon Elastic Kubernetes Service, or EKS. So EKS is a managed version of Kubernetes that abstracts having to install, operate, and maintain your own Kubernetes control plane or your nodes. So if you're not familiar with Kubernetes, if you didn't give me a thumbs up here, it's an open source system for automating, deploying, scaling, and management of containerized apps. So what EKS specifically does is it does a few things that makes it manage Kubernetes. So it runs and scales the Kubernetes control plane across multiple AWS availability zones, and that ensures high availability. It also automatically scales that control plane instances based on the load, detects and replaces unhealthy control plane instances, and it provides automated version updates and patching for them. So Kubernetes has been labeled as to this point, the de facto standard when it comes to building microservices-based solutions, because of exceptional reliability and stability built into the framework due to high fault tolerance clustering. There are a ton of other reasons why people should use Kubernetes in certain use cases. I'm not a Kubernetes expert, but I've just listed a few things that make building highly scalable microservice type applications really, really effective. And when you want to choose between EKS and ECS for container orchestration, the largest thing that you want to consider is how you want services such as networking, other components like that handled. So ECS relies on AWS provided services like application load balancer, Route 53, and some others. EKS handles all of these mechanisms internally because those are core components of Kubernetes. EKS also runs up-to-date versions of the open source Kubernetes software. So all of these plugins and tooling that you get from the Kubernetes community, they're available for EKS. Applications that are running on EKS are fully compatible with applications running in any standard Kubernetes environment, whether that's on-prem, data centers, or other public clouds. So this means that you can migrate your existing Kubernetes clusters, Kubernetes applications to EKS without having to change any code. So that's pretty exciting. With both ECS and EKS, there is still some management of the servers or instances of these two, but not as much as owning these two instances outright, but it isn't a completely turnkey approach. If you're looking for more set and forget and you have options to customize in the future, there is AWS Fargate. And AWS Fargate is a technology that you can use with ECS and EKS to run your containers without having to manage them at all. So no provisioning, no configuration, no scaling required. And when you run your Amazon ECS tasks and services with the Fargate launch type or the Fargate capacity provider, your application, you package your application in containers, you specify that operating system. So things like CPU and latency, CPU and memory requirements, define your networking and your security policies, and then you just launch the application. So each Fargate task has its own isolation boundary, and that does not share the underlying kernel, CPU resources, memory resources, or the network interface with any other task. And since all the management is done for you, you can tap into great cost savings as you only pay for the resources you consume while you're running. So there's no overhead of EC2 instances running always on. So this enables more flexibility to scale up and scale down, so bringing cost optimization even lower than before. So what is the actual difference? What sets Fargate apart from just doing, just managing ECS, for instance, yourself? So with both approaches, you still must build the container image. But after that's where Fargate really provides some value. So with Fargate, you don't have to define and deploy the EC2 instances. You don't have to provision or manage the computer memory. You don't have to isolate the applications. You don't have to even manage the running applications and their infrastructure. So with Fargate, you just build that application, you define how much compute the app needs, and you just run it. The difference is not having to properly define or deploy or manage the underlying infrastructure. So you just define what the app needs and let Fargate do the rest. All right. We've talked a lot about containers, a lot about container orchestration, a lot of managing containers in general. And I want to talk a little bit about what if I just want a containerized app in the cloud without having to think about it? So in that case, AWS App Runner is a great option for you. AWS App Runner, it's a fully managed service. So we've talked about some not so managed services, some kind of managed services, some almost all the way managed service. App Runner is fully managed. So what that means is that no prior infrastructure experience required. You start with your source code or a container image. So source code can be in GitHub, for instance, and App Runner builds and deploys the web application automatically. It then takes those services and deploys them to a private Amazon VPC. With App Runner, rather than thinking about servers or scaling, you have more time to focus on your applications. When you connect App Runner to your code repository or to that image registry, App Runner automatically builds and deploys them when updates to your source code are done or changes to your image are done. App Runner also provides features out of the box like load balancing, auto scaling, HTTPS on by default. So you don't need to spend additional time configuring these things inside of the AWS console that are already there for you. App Runner also makes it seamless to monitor and optimize your containerized applications by providing build, deployment, and runtime logs. You can also get a full set of compute metrics with built-in Amazon CloudWatch integration. And to get started with App Runner, simply just point it at a GitHub repo or an ECR image, and the framework will do all the necessary steps to get that app to the cloud. And I wanted to show you a really interesting demo of taking a .NET application, containerizing it, and deploying it to App Runner using the .NET Deploy global tool. So let's hop over here. Let's stop this running instance here. I'm going to close that tab. Oh, I closed the wrong thing. Let's just go exit. Let's go to my D drive and then C. Where's that? AWS demos, .NET App Runner, .NET App Runner. All right. So I just have just a simple, let's just list it out. It's a simple application that I built yesterday to basically show some information about the host that your container is running on. So let me just, for instance, let me just open this up in Visual Studio Code. All righty. So nothing crazy here. So I have a .NET 7 application. I don't have any container information here. I don't have any Docker files in here, right? What I want to be able to do is I want to take this app and I want to deploy it to AWS as a container without having to create services in AWS or create a Docker file or do a bunch of other stuff. Let's do that really quickly. So I can use the .NET Global tool, .NET AWS, which is free and open on GitHub. And all I got to do is .NET AWS deploy. And what this does is it'll walk me through a process of interactive process to deploy this application to AWS. I've already done a deployment yesterday to test, but let's actually just create a new cloud application. So I'm going to select option 2, and it gives me, based on my code base, some recommended deployment options. So I can use Amazon ECS using Fargate, or in this case, I can do App Runner. So what's important here is that it will build a container image and deploy that container image to AWS. So it'll create a Docker file for me. It'll deploy that Docker file to Amazon ECR, and then it'll send a trigger to App Runner to say, hey, use this ECR image to build an application. So I'm going to go with option number 2 because I just want my app in the cloud. And then I'm going to specify the name of my cloud deployment. And then something really interesting is going to happen. It's going to say, okay, here's some basic settings. I'm just going to say, sure. And then, I don't know if you saw that, something happened in Visual Studio Code. A Docker file showed up. So what the .NET Deploy tool, what it does is it actually says, hey, your application is a .NET 7 application. It's a web application, and let's just go ahead and get this, let's containerize this application and then deploy it to App Runner. So because I'm respectful of everybody's time, I'm just going to go over really quickly what's actually happening here. So we're building my container image. We're pushing that container image to ECR right now. And there's going to be another command right here, which is basically saying, hey, AWS App Runner, use this particular ECR image to build our application. So this entire process, because I'm building out compute in AWS, I'm deploying, I'm doing some, I'm pushing an image. I'm also building out and pulling that down. So I actually did this morning. So I'm doing that thing where I show you a demo and then I'm actually showing you a completed version of that demo because that's what lame people do, like me. So here I have a .NET App Runner service that exists As you can see, like I have access to health checks and all of my logging here. I can go in the configuration tab and easily do things like configure auto scaling. So for instance, if I wanted to scale this up, I can say, okay, I want my concurrent numbers to go down, but I want the maximum size to go up or what have you, right? So let's just open this up and see what it is. So this is just a simple application that I wrote that shows me the host information for this particular container image, what's running on, right? So as you can see, it's running Linux, Amazon Linux 2, which is a Amazon specific flavor of Linux. It shows me the available memory that I have, my CPU, it shows me that it's containerized, and it shows me the IP addresses of that particular image, right? So nothing crazy here, but it's an application that I had on my machine. I ran one command and went through a couple of steps, and now I have a Dockerized version of an application in the cloud, and I didn't have to configure anything. I didn't even have to build a Docker image or the Docker file, which I think is really, really cool. So yeah, let's see. Let me take a look at the chat. All right. I'm gonna go over and look at some of these questions. So we have a service that is hosted on a Lambda behind API gateway that proxies to some different EC instances depending on a route. Will this be a good candidate for using AWS Fargate? So the application on EC2s are legacy applications that we don't really want to touch. If these are APIs, my recommendation is probably sticking them behind Lambda is still a good option for you. The problem with if you're using Lambdas to direct traffic into different EC2 instances, you might want to look at some of the containerized offerings, right? Because what makes Fargate really, really interesting is a lot of the management of these containers or these container platforms is just done for you, right? You have to give it a template of what you actually want, but then after that, it's all handled. Hopefully that's helpful, Chris. If you want to throw in a follow-up, you definitely can. Oh, my friend Daniel Lawson's here. So hey, Daniel. So what we got here? There's a lot of text. A big monolith .NET app. I have a big .NET app that's running EC2. To save costs on compute, I want to make my monolith serverless. So meaning I want the EC2 hosting the app to run. I want the EC2 hosting the app to run only when there's a request to the app. The app is a .NET Core MVC app. So what is the best option for this use case? So my recommendation in this case would be AWS Fargate, because AWS Fargate, it's a serverless compute platform. So what that actually means is that if there's no load to your application, it scales all the way down. So you're only paying for when your app's actually running. So that's probably the most straightforward option. Lightsail is also interesting because if you're familiar with like DigitalOcean, like the droplets in DigitalOcean, like the really, really low cost compute, Lightsail is kind of like that. So it's like VMs for like $5 a month. So that's what's really, really interesting about that. But if you want like a really like you just want to walk away from the management completely, Fargate might be a really good option for you. All right. What else do we got here? What support does AWS have for private NuGet packages? That's a common use case for a non-standard Docker file. So so most of that private NuGet package stuff is actually handled in the application using like NuGet config, right? So if you have a NuGet config in your application, then you should be good to go. I haven't played around with this personally, but you know, in my experiences with other clouds, having a NuGet config file with those those key and secret is how you kind of get that thing going. And you can have that stored like in secrets, like in GitHub Actions or in Azure DevOps, or even in some of our code suite and for AWS things. All right. Carl says, I didn't know about the existence of the CLI tool. That's really cool. It removes a big barrier to trying Amazon. That's right, Carl. Just literally download the global tool and run it, and then write me a check because I'm down. I want some money. All right, interesting. The secret memory usage limit is shown in your demo app. Any idea how to get Kubernetes or any AWS component to sig term an application before it exceeds memory allocation and gets killed? I have this set, I think correctly, but I get this a lot in AKS on Azure. I'm going to be 100% honest with you. Not a Kubernetes guy. But if you want to just, if you want to, send me a tweet with your direct questions, I can ask our folks over on the EKS side if there's a way to, I guess, provision more memory in this case, or kill the app before it kind of hits that memory limit. I just don't want to give you an incorrect answer. But yeah, Isaac Levin on Twitter, if you want to get kind of put in touch with some folks there to be some helpful. All right. Daniel says, thanks. Jason says, thanks. Right. All the questions are good. All right. So let's keep on trucking. That's a US thing. Sorry. People probably don't know what that means in the UK. So let's talk now. We're talking about like, we've gone down this abstraction, right? We started off with like a VM, and then we went to like a managed version of VM, and then we went to containers. But containers, even though they're awesome, there is overhead in containers. Like even with App Runner, like there is a little bit of overhead, right? But what if you just want some .NET code and you want that code to just run? So if you're writing code that just needs to run, if you're writing code that just needs to run based on a specific event, for instance, at a scheduled time, when a database record gets updated, or even an HTTP request, AWS Lambda is a really, really great option. AWS Lambda, it's a serverless compute engine that allows you to run your code without provisioning, managing, or frankly, caring about the underlying infrastructure to run your app. So this is a great option if you're building apps that follow some event-driven architecture, as well as apps that don't have some state that you need to worry about. And when you are building web applications that are APIs, we need to be able to effectively route traffic. So Amazon API Gateway is a fully managed service that enables developers to create, publish, maintain, monitor, and secure those API scale. There's other serverless offerings as well that we're not going to talk about here, but like AWS Amplify allows you to host static applications in AWS. So for instance, if you're building a .NET app with Blazor WASM, you can take advantage of something like AWS Amplify. We're not talking about that here, but it's just something, it's another offering to call out. So more than likely, give me a thumbs up or a plus in the chat if you've heard of AWS Lambda before, and you have a rough idea of what it is to an extent. So if you don't know or haven't heard, AWS Lambda, it's a service that allows you to run a function or a smaller piece of functionality on demand without the need to manage the underlying infrastructure at all. So the phrase commonly used in the industry for these sort of things is serverless, because the thought is that we think about our code more and the server less. So regardless of what you think about that quote or that phrase, like the ability to focus on your applications and your functionality, it's quite valuable. So no other scenario, to me at least, is more interesting when you want to build an event-driven solution. So when I say event-driven, like think about how we build apps, right? Usually we have to respond to some event taking place. So that event could be a database record getting updated, a file gets dropped into a storage bucket, or maybe you have something that needs to run at a particular time of the day, like to compute files or something. So in this scenario, the perfect thing to use is AWS Lambda, because you can configure these triggers right in the AWS console. And then you can seamlessly see these executions of your code and then use those use cases as you see fit. Another great example of when to use AWS Lambda is when scale is really, really important. So you imagine you're a retail company in the US, it's Black Friday, you have an e-commerce store, Black Friday being the Friday after Thanksgiving. It's like the most important holiday shopping of the year for the States. And your bottom line is immediately dependent on how your website reacts to the demand of customers. So AWS Lambda automatically scales based on load. So you can rest assured that your app will be scalable and robust when you need it the most. The number one benefit, in my opinion, when you use serverless technologies like AWS Lambda is the pricing model. Since you only pay for when your AWS Lambda function runs, you get exceptional value because you truly pay for when your app is bringing business value. So I've had conversations with customers all the time, and they're always shocked when they first start trying AWS Lambda because the consumption bill is so low. Obviously, if you're running trillions and trillions of transactions, it can get not cheap, but initially when you're first getting started, it's very, very expensive. And with Amazon free tier, AWS free tier, you get it. I don't remember the exact number, 100,000 transactions a day or transactions a month for free. So play around with AWS Lambda if you haven't. It's definitely super awesome. And I mentioned earlier, we have accessible metrics and execution telemetry data built in to the AWS console for your running AWS Lambda functions. So that's incredibly helpful to get an idea of where your apps are and how they're behaving in the wild. All right. So one often used example for AWS Lambda is APIs that are available over REST. So when you have APIs, we want to ensure they're secure and accessible no matter where your customers are. And when we're building APIs, we have a managed API service, and that's called Amazon API Gateway. Like I mentioned, it's a fully managed service that makes it easy for developers to publish, maintain, secure, and operate APIs at any scale. It is a pay-as-you-go service that takes care of all the undifferentiated heavy lifting involved in securely and reliably running APIs at scale. You can authorize and verify API requests to AWS services. So API Gateway allows you to leverage AWS identity and IAM policies to secure your APIs and the underlying services they consume. One great example is using AWS Lambda functions to verify and authorize bearer tokens like JWT tokens or SAML assertions. On a side note, I know they're called JOTs. I'm always going to say JWT. I'm sorry, whatever. And with mobile applications and IoT devices becoming more and more prevalent as platforms to build applications on, the need to have a backend service that provides a set of APIs to those client applications is really, really valuable. So let's do a quick demo of showcasing building serverless apps, .NET serverless apps with AWS Lambda. So I'm going to open everybody's favorite tool, Visual Studio. So I have a Amazon Lambda or AWS Lambda function project. So if you want to get started with AWS Lambda, we have templates available in Visual Studio. We have testing frameworks available in Visual Studio. So this particular instance, it's a .NET application. And all it does is it's simple. It takes a string and it's just uppercase. So, and that's what you see in this code here, this to upper. But one thing that's very, very interesting about building applications in Visual Studio with AWS Lambda is we have a mock Lambda test tool. And you're probably asking me, what is that? If I click this, what it'll actually do is it'll actually open up a UI that I can then test my applications in, test my AWS Lambda functions locally in an experience that's variable for me. So for instance, in this particular case, let's just say hello. You can execute this function and the output is the upper version of hello, right? But this tool has all sorts of requests. So you can do, if you're building apps for Amazon Alexa, if you're building different apps that depend on certain events, we have example requests for all those sort of things. So that's really, really cool. Let's do this. What I can actually do here is I can actually also deploy directly to AWS this Lambda function. So I can right click here and I can publish to AWS Lambda. And I've already done this, but I can specify the function name, which is coming from AWS, and I can specify the configuration and all that sort of great stuff and hit next. And then the next step, if I want to, is I can configure the memory and different like I can specify a particular subnet that I want to run it under, and I can handle dead letter queue and all that stuff. Or I can just click upload. And what this will do is it'll publish my .NET application, and it'll take that publish directory, it'll zip it up, and it'll push it up to AWS Lambda. And once that publish is done, there's actually going to be a UI that opens on my screen in us right now that allows me to actually test that recently deployed Lambda function. So I can then, like I said earlier, I can do hello. I click this button, my response is hello, right? So that's pretty cool. But I want to do one additional thing. I want to take this API that I just built and I want to put it behind API Gateway because I want some scale there. So this is my Lambda function here. As you can see, there's .NET Lambda. I can add some triggers and I can add some destinations if I want. But what I want to do is I actually want to create an API Gateway. So if I just search in the AWS console for API Gateway, and then I go to, and then I can specify what kind of API. Since this is an HTTP application, I'm just going to specify API. So I'm going to build, and then I'm going to add an integration. And I'm going to say, I want this to be Lambda. And then I specify my Lambda function. So there you go. So that's the particular region where my application is running. And that's my Lambda function resource name. And then I just give it a name. Let's just call this .NET. I can give it any name I want. And then the next thing that I do is I configure the routes. So whenever somebody hits this particular route on my API Gateway, it's going to route that traffic directly to my Lambda function. Click next. I can specify different configurable environments. Let's just leave that default. And then create. So once this is done, I have a API Gateway in front of my Lambda function. So if I invoke this URL here, let's actually do this. Let's invoke this URL and let's just do this like inside of Postman. So I had that here. And then remember that the particular, what was it, .NET? Yeah, let's click on this stage name. And I can take a look here. I can specify, I believe it was .NET. Yep. So go .NET. .NET. And then I can just put a body in here. Let's just have it be a raw body. And then it could be, hello. Message not found, because I probably don't remember what the endpoint was for it.
Oh, you need to post, I think, rather than get.
Yeah, it was also .NET Lambda. Okay. Yeah. So if I send this here, message internal server error because something's not working. Let's try a post like that, like the gentleman said. No. Let's try to remove these quotes. I promise this works. I don't know why it's not working. All of a sudden it worked 20 minutes ago. I'm probably just doing something wrong. But basically, if I wanted to
displease the demo gods.
Yeah, I was doing so good too. Yeah, so I guess the long and short of actually, let's just do this because I want people to believe me. Let's just update this a little bit. Let's just change the output because I think that the issue is related to hello, Bristol. All right, and let's redeploy this. Oops, wrong button. All right, let's take this Lambda function. Let's just republish it. So upload. So this will take another second. It's going to take that application that I just built. It's going to publish it, and then it's going to deploy out. Let's now I don't need a sample request. So it says hello Bristol. So if I go back to Postman here and I take out this body and just change this to like a get. Hello Bristol. All right. So it was to do with how I was formatting the how I was specifying the post stuff. But anyway, so simple demos today of just showing how we can host different types of applications written in .NET in AWS. So hopefully there was something there that was valuable to some folks. So that is my talk, like I mentioned earlier. So if you want to chat more with me, Isaac R. Levin on Twitter, Twitch, or GitHub. Definitely want to chat with you more about really interesting things on AWS and .NET in general. I'm gonna if you have questions, feel free to throw them in the chat. I'm gonna scroll up and see, make sure that I didn't miss anything. But if you didn't have any questions, this was a pleasure. Daniel Lawson has a question. When will .NET 7 Linux AMI be available on AWS instance types? We're currently working and figuring out what .NET 7 look like on AWS. Full disclosure, it's typically AWS policy to not support non-LTS versions of any software, of any platform. So that's just not .NET, that's Node, that's Python, that's PHP, that's Java, right? So what we're trying to do is convince our friends over in some of these different orgs that .NET 7 is really impactful and it provides excellent experience for our customers. So the short answer to your question is, Daniel, to be determined. But what I do recommend is that if you want to go down the path of hosting or building .NET applications on AWS today, .NET 7 specifically, you have a few options. One, you can go down the not managed route, like EC2 or Lightsail, and spin up the .NET 7 SDK on there, or the .NET 7 runtime on there. You can also deploy applications using the self-contained way, which includes the entire .NET 7 runtime as a part of the deployment process, or you can put it in a container, right? So if you have a container with .NET 7 on it, your application is .NET 7, you should be good to go. I know it's not the best scenario, but we're looking at options, especially for Lambda, for instance, with native AOT. We're looking at trying to figure out effective ways to make that functionality accessible, because we understand with native AOT, you solve a lot of problems related to like cold start of functions and things like that. And being able to provide those valuable insights from the .NET team to our customers is really important. All right, scrolling. I was going to ask if there was a free tier to AWS Lambda, but you answered there's 100K free requests. Don't quote me 100%, but if you say AWS free tier Lambda, it'll tell you exactly. I believe it's a lot. It's definitely enough for you to play around with without inferring some cost. Chris Wood says, we're currently hosting our UI behind a Lambda on API gateway. Is there a practice you would recommend, or should we use that approach? I mean, Lambdas are, you can host apps with APIs behind Lambda, that's totally fine. There's probably other services that are, I guess, more, what's the best way to phrase this? Not ideal, but there's ones that you would expect, because Lambdas are typically for APIs. But if you don't have any negative experiences. Like for instance, like you could use like one of our container offerings, for instance, to host that. But if you're not experiencing any bad experiences, like leave it where it is. I think that's totally fine. Customers do that today. Are we able to use API gateway to manage request throttling or IP restriction? The answer is yes. That's one of the key principles of being able to, have a fully managed API service, is really being able to control how your environment is, right? So, things like IP restriction and stuff like that. And then like with the new rate limiting built into .NET, like you can really make sure your applications are not being abused, right? So that's really, really important to call out. API gateway authorization is awesome. I totally agree. The Lambda test tool is pretty impressive. Azure Functions can be a kind of counterintuitive to work on locally. I'm not going to speak ill of other cloud providers, but I really love the Lambda mock test tool. How easy it is to containerize Lambda functions. I mean, I would say it is, it's of a similar experience to doing the same thing in other cloud providers. It's not super difficult. There is really good documentation on it. So definitely check that out if you are interested. Lambda running on ARM with .NET is possible. Not Jose, not this time, but if it's something that you feel like that there's interest in, please let us know. I haven't heard of any serverless architecture that allows you that runs on ARM. But if it's something that you think that's interesting, please let me know. I would love to kind of hear, because we're having a conversation about that actually last week. I guess the title of this talk, but if you write a Lambda in Python, you can type them straight into AWS. Great for POCs. That's true. So like if you have a non-compiled language like Node or Python, really, really cool to be able to play around with Lambdas right from the AWS console. All right. And then some people saying thank you. Ravi says, having used Lambda in the past, I have seen that what they did means issue with cold start. You look at an API hosted as Lambda. So specifically around cold start, right? So cold start is a problem regardless of the cloud provider you use, for instance, right? One thing to call out is that any JITted application is going to have a cold start when it's being started up the first time. For instance, Azure Function has the same issue. So one of the ways that you can get around that, at least in an AWS world, is you can take advantage of .NET 7 native AOT, which the last performance benchmarks that I saw decreases cold start times by about 83%. So again, native AOT, which is available in .NET 7, we're working on there's already templates for it, and we're just working on making sure that the runtime is going to exist in Lambda, and they should be able to use those things as needed. All right. Ed says, I'd be interested to know any compelling reasons you think someone should choose AWS over Azure. Thanks for the presentation. I will say this. I'm not really in the world of saying you should move off of Azure to AWS. I'm also, when I used to work at Microsoft, I used to say the same thing. Like, there's no reason to move from AWS to Azure unless there's some large compelling reason. My thought is more, if you're not in the cloud today and you can get value out of the cloud, you should definitely look at AWS as a respectable option for hosting .NET applications. I'm not going to say it's the best experience. I'm also not going to say Azure is the best experience. There's a lot of edge cases for Azure, for instance, for .NET apps. And that just is what it is, because nothing is perfect. But I think the biggest thing that I see is providing folks, like talking to you lovely folks across the pond, like about just showing that AWS, you can look, in the span of an hour, however long it's been, I took 3 different kinds of applications, hosted them in 3 different types of AWS services, and it wasn't challenging. So I think, there's something to say about giving people options, because the options only breed positive outcomes for customers, right? So I hope that was helpful. All right. And I think that's the end of my chat. Cool.